Hi, and welcome to our presentation of how we made a Magnolia-based e-business site more robust. So now we're no longer afraid of what would happen if some clown comes along and pulls the plug. What we're going to present today, we're talking about a relatively small site, and it's definitely not rocket science, but we hope that you might take away something useful here or there, and that's why we are going to be putting all the documentation on our website at fastforward.ch/unconf. I'm Anne. Feel free to write if you still have questions after today's talk. We're Fast Forward, based in Bern, Switzerland. We do mostly Magnolia integrations, almost exclusively, with mobile and Internet of Things applications thrown in. We have been doing Magnolia since its first public release. We're all officially certified on Magnolia 5, and we have more experience migrating to Magnolia 5 than we really care for. If you want to collaborate, give us a call. We really love to work with other Magnolia teams. Our client in this case is Schweizmobil, or Switzerland Mobility. They're a Swiss organization providing a network of trails throughout Switzerland for hiking, biking, rollerblading, and even kayaking, I believe. They provide trail signs, publish guidebooks, and have online maps, both as a website and as an app. The online maps with the official tours layered on top are absolutely free to use, so you can plan a cool outing for Friday. But there are some premium features that are really nice, such as drawing your own route and saving it. That tells you mileage and elevation gain, so you can figure out how long approximately it's going to take you to hike from on that specific route that you want to go. You can export your route, and you can use portions of the maps offline in the app should you go to an area in the mountains that might have sketchy cell reception. This is where we come into play. We put together the website to promote these premium features, where you can sign up for them, and where you will find answers to frequently asked questions. The website will have a nice responsive interface with the next release that's coming out in the next couple weeks. We did this with Bootstrap. We have live server-side validation. We added a coupon functionality that's been in there for a long time, before Magnolia came up with a coupons app. And we've added e-payment. So let's look at the system architecture. We have the maps that are done by another Swiss company specializing in geodata. We have an address database with a company that does direct mailing. So they actually mail you an old-fashioned paper bill and a card. We're still working with the client on improving that since we're talking about an online service. We have our website in the center selling the premium subscription. We've added user authentication, e-payment, and in the upcoming release, the Swiss Pass gives you a rebate. That's the new electronic pass by the Swiss transportation authorities. And if I were a salesperson, I would tell you to just connect all these systems and we'll be fine. But what we want to do now is look at these connections in detail, because we have problem number one, unreliable data exchange. So on one side, we have Magnolia. On the other side, we used to have the address database. And in between, we have a relatively old-fashioned web service that might just go away. And we're left to help our client pick out the bits and pieces of the relatively valuable orders in our logs. That is not very cool for our customers, the end user, I should say, because typically they sign up on a Friday night or Saturday morning and want to plan a tour for that weekend right then and there. They don't want to wait until Monday morning when we figured things out. So what did we do about these shaky connections? We needed to make systems independent so that our website will be up and running and open for business even if the address database in the backend is not there. And of course, the map system needs to always be available with the premium features after people have already spent their money. Obviously, requirement number 2, we don't want to lose any data. And also, requirement number 3, we want things to sync up automatically after a service comes back up. So we got together with our friends at fellow Magnolia partner Blue Sky, sitting there in the audience, to talk about things, throw around ideas. We're added user authentication with an LDAP master on the same server infrastructure as the Magnolia site, and then a slave on each map instance, which I believe they're hosted at Amazon. So that's our decoupling solution number 1. Decoupling solution number 2 is that we were able to convince our client to move the master database to Magnolia and then use the original database essentially as a slave. Sometimes we still need to move updates in the other direction, so from the slave back to us. So if I forget to pay my bill, that needs to be reflected in our database so that I can no longer use the premium features. So what we did there is a very simple and stupid thing, is to, they provide the updates in text files, and we go get them essentially with secure copy and read the updates, process them, and move the files into a different folder so we don't reprocess them the next time around. That we are doing in a custom importer, which is like based on an importer in the data module, Magnolia's data module, that triggers import jobs with the Magnolia Scheduler module. So we're using some nice Magnolia features there that are cool to know about. And we're happy to that they're actually still working in Magnolia 5. And as a shout out to Magnolia people, if you're thinking about scrapping the data module, that might be something worth saving. Decoupling solution number 3 is, instead of sending the orders straight to the web service, that may go away at any time, we added a message queue and are sending the messages to the message queue first, where they can safely wait until the web service is available to receive the messages again. We have one more requirement from the client, that is to keep things as simple as possible. So they were not very happy about the thought of having yet another service, the message queue, that needs to be hosted, and somebody worrying about it being there. So what we did was to integrate the message queue into Magnolia, and with starting the Tomcat, the message queue is also up and ready. So we used Apache MQ, Active MQ to implement this a couple years ago when we first set this up. And we actually share it between the author and public instances because obviously the messages are produced on the public side where the orders come in, but we want to also consume them on the author side, where we provide an app where the client can look into and see what the status is of the queue. And with that, we're getting into implementation details, and I'm handing over to my colleague Cedric.
Okay, hello. Yes, this is me. I'm Cedric. I'm going to give you some details on implementation on this project, especially on the ActiveMQ, some pitfalls and challenges we faced. Like Anne said before, we had the requirement to run author and public and the ActiveMQ in one and the same Java VM in the same Tomcat. And usually, when you use third-party libraries in Magnolia, or in a Tomcat, you just put them into the lib directory of the unique Tomcat web apps. As you may know, Tomcat separates web apps by using unique class loaders for each web app. This means that you cannot communicate between different web apps directly. You cannot use classes from the other web app. But we wanted to have ActiveMQ running in this JVM, but not inside the web app, but somehow outside in a way that we could access it from any instance, in this case, author and public. To do so, Tomcat provides a lib directory which Tomcat provides a third class loader, which is a parent to the author and public class loaders. It's called the common class loader. And you can load classes by putting chars into the lib directory of the Tomcat itself. As a next step, to instantiate our message queue classes, we use JNDI. As a first step, we had to define a resource in the server.xml, which contains information about the class we're using, for example, or the broker URL. In this case, everything runs within the JVM. So next step, we have to define a resource link so we can access it later within the Java code. This is really helpful because we have just one configuration globally for the whole Tomcat, and we can access one and the same connection factory or use the same connection of ActiveMQ from any instance. In our case, of course, just two, author and public. So what happens when we produce a message? First of all, we are using a shared repository. This is helpful because orders from public users happen on the public instance of Magnolia. So we have to save this data somewhere. Using a shared repository allows us to write it into this repo, and the same data will be available on the author instance too, without having to activate or send data somehow else. There's just one disadvantage. There's a slight time lag with synchronization of repositories between multiple instances using a shared repo. This is about 1 or 2 seconds, so when you write something into the repo from public, for example, it will take 1 or 2 seconds until the changes are visible from the author instance. On the other hand, our ActiveMQ is solely running inside the JVM and thus pretty fast. So what happens now? After finishing an order, we save order data right into the repository and immediately create a message for the message queue, which arrives pretty quickly on author. An author at message consumer handles this task, which is basically writing into the remote database. And after finishing this task, receiving the answer from the remote database, it tries to update our order data, like annotating that we successfully sent it to the remote database. And of course, if the shared repository hasn't synchronized yet, we will run into inconsistencies. What we did to resolve this was just to delay our message in the message queue by a couple of seconds. Now let's look at the author instance. We run our consumers only on the author instances, and we configure them using a properties file. Now there's another pitfall. If you use single war deployment, you will end up with having the same configuration in all instances of Magnolia. So we always have to actively make sure we disable them on any public instance. Right now it's just one. And of course enable it in other instances. Okay, sorry. That's that. The next pitfall we faced was that, of course, our message queue or our message consumer is running outside of Magnolia's filter chain, which makes perfect sense, but there's one difficulty. If it doesn't run through the filter chain first or isn't running in this thread, there will be no Magnolia context. Get instance will just return null. So to resolve this problem, we first check whether there's an instance, and if not, we manually instantiate a simple context, do our work, and afterwards we release it again. Okay, I'm going to give you a real quick demo. What I'm going to show you is what happens if we try to register, or if we register as a new user of Schweiz Mobil. Let's say your name is Johnny, with one N is okay. Johnny Doe, street is test, 1, 2, 3, whatever. By the way, you see live validation via Ajax. It becomes green. Our zip is 308. Anyway, if we mistype when typing an email address, like if we forget a dot or whatever, we get a notification. Just a small detail. Now, as said before, and already mentioned that, we have two kinds of coupons. There's one specific for Schweiz Mobil, implemented by us, and the second one, Swiss Pass, which is a quite new system by the Swiss railing company. Right now, it directly connects to the servers of Swiss Pass, checks whether this exists, looks good. We want to pay by bill, accept terms and services. Now we review that. It's just a review page. It's not sent yet. Let me real quickly clear the log. And now we send our order. And now for the user, everything is done here. They can burn their computer or whatever. And we have an app now, which handles the message queue. So we can look into the message queue. And we see there are messages that are still due to be sent. By the way, there are 3 queues. One for the bill writer company, and the other one for Swiss Pass. And the third one, it's a dead letter queue. Dead letter queue means that some messages could not be sent. For example, we still see that there is one in the Swiss Pass queue. Looks like something's wrong. And it will try again and again, a couple of times, depending on configuration. And if it failed enough times, it will end up in the dead letter queue. We see in the log that there are some faults, some errors. SOAP fault exception. We manually just broke the connection a couple of seconds ago. Okay, right now you see it's in the dead letter queue. And you see there's a second entry here, which was dead before. Both queues here are empty. We can say from that one succeeded and another one failed. And now they would call us, and we would call the company and ask if they can fix their servers. And once everything is up and running again, we would try to resend the message. And of course, if we don't want to resend it, if we think, no, that's too old, or the customer called us because he was waiting too long and we created the order manually or whatever, we can just delete it. And now let's check again. It's again in the queue. And there's another app, by the way, where the really finished orders can be found. In this case, we just have test orders. You can search for dates. That's what we did.